Okay, this is a video about using a definite integral to compute the total change of a quantity. And so we have an example written out here. So some radioactive substance is decaying at a rate of minus 0.25 e to the minus 0.058 t grams per day. So t is in days. Alright, and first of all, notice that this substance is decaying, and this says it's decaying at a rate of this. And notice that this expression is always negative, so its rate of change is negative, which means it's decreasing, which means it's decaying. So the sign here makes sense. And what we'd like to know is how much of this substance has dissipated or disappeared in the first 10 days. So first of all, we should recall what the fundamental theorem of calculus says. So the fundamental theorem of calculus tells us one way to interpret this is that the integral of a rate equals total change. More specifically, the definite integral from a to b of some rate is total change. Total change from a to b. Okay, so what we were given is the rate at which this substance is decaying. So if we want to know how much is dissipated, in other words, how much disappeared, that's the same as saying the total change in the amount of this substance. So if we integrate its rate with the correct limits, we should get the total change from the lower limit to the upper limit. So in other words, we want to integrate the rate of change, which is this function. So it's minus 0.25 e to the minus 0.058 t dt. And what do we want for our limits? Well, we want to know how much disappeared in the first 10 days. So the start is at t equals 0, and we want to know the total change in between t equals 0 and t equals 10 days. So now we just have to compute this integral. This represents a number, and that should be the number that we want. Okay, so let's go ahead and do this by hand for practice, if nothing else. So first of all, how do I compute this? Well, we can either use a substitution, or we even have been given a formula for something like this, because this has the form e to the kt. And so an antiderivative of e to the kt is 1 over k times e to the kt. So in other words, I need to divide minus 0.25 by minus 0.058. And so what does that equal if I divide? So I'll write this out. So minus 0.25 over minus 0.058 is approximately, and you can do this with your calculator, it's approximately 4.31. And so this is actually already an approximation, but I don't want to deal with a lot of decimals, so I'll just call this 4.31. Make sure my decimal is still in there. Okay, and then we just repeat the e to the kt part, so I have e to the minus 0.058 times t. And then I recall what my limits are. My lower limit is 0, and my upper limit is 10. Okay, and in evaluating this, I'm probably going to have to, well, this part will be exactly the following. And here's a trick when you're evaluating your antiderivative at an endpoint. If you have a common factor here, if you have a multiplicative factor, it can just come out. For the same reason that we could have just pulled this number out here in the first place. But so we can call this 4.31 times this quantity, e to the minus 0.058 t, evaluated at 0 and 10. And so further, we can say that this is, well, how do I compute this part? Well, first of all, I need to copy down my 4.31. And what do I get for the first part? Well, I plug in 10 for t first, and that just has the effect of moving the decimal over, so I get e to the minus 0.58. And subtract, subtract when t equals 0. So I evaluate this at t equals 0, and I just get e to the 0, which is 1. So this answer is complete. This is a number, but let's throw it into our calculator to approximate it, to get something a little more meaningful. And it turns out to be minus, well, at least roughly speaking, minus 1.89. Now I got a minus here, and that minus does make sense, because we wanted to find out how much it decayed, and it was indeed decaying. Since the derivative is negative, this function is decreasing, and we found the total change, and we got negative total change, which means the amount of this substance decreased, and that makes sense. So that's good. And just to be complete, what are the units of this? Well, they're the units of this integral, which are the units of this function, right, which is in grams per day, times the units of t, which is days. And then the units of days cancel, and we just get grams, which makes sense. So the total change in this substance was minus 1.8, or approximately at least minus 1.89 grams, or so the substance decayed by 1.89 grams. And that concludes our video.